All right. Hello. Welcome back. For this lesson, I want to talk about what's called the celestial sphere. The celestial sphere, it describes our apparent view of the sky. So if you watch a time lapse of the night sky, you will notice stars rising and setting, and it kind of looks like the sky is moving around us, like we are in the middle of a slowly rotating sphere. Of course, what's really happening is that the Earth is spinning, but we can use this idea of being inside a big sphere to describe positions in the sky. So I try to start out these little lectures by giving you something to think about at the beginning of each of these. And I want you to look at this picture and think about it. So these are what are called star trails. It's basically a type of picture you can get by taking a very long exposure image. What I want you to think about as we go through these slides is, where is this, right? Where is this, has this picture been taken? We will know the answer to this by the end of this lesson. Okay, so back to the celestial sphere. So we can define the celestial sphere by projecting Earth's coordinates onto like an enclosing dome, right? This view on your screen is what's called kind of the horizon view. And we can identify a few important points. Like here we have, this is our imaginary dome, right? Our celestial sphere. Here's the ground that we're walking on with dinosaurs. Okay, so let's look at some important features. So we have north marked here, south marked here, but there's also a zenith. So zenith is the point directly overhead you. It is the top of the sky straight overhead. So for Earth, we can talk about having a North Pole, and we can do the same thing for the celestial sphere. So this line here represents the celestial North Pole. You'll often see it as NCP. Um, so where this is depends on your latitude on Earth. So here in Albany, we're at about 42 degrees north latitude. So um, the North Celestial Pole is about 42 degrees above the ground. And it is denoted for us in the Northern Hemisphere by Polaris, right? The North Star. You'll see Polaris about 42 degrees above the ground. And the North Celestial Pole is the projection of Earth's axis out into space. So 90 degrees from the North Celestial Pole is the celestial equator. So if the North Celestial Pole is Earth's axis projected out into space, then the celestial equator is Earth's equator projected out into space as well. This also happens to be the path of the sun on the equinoxes. So the celestial equator is also the path of the sun on the equinox. On the June and December solstices, the path can either be 23 degrees above the celestial equator or 23 degrees below the celestial equator. So these dotted lines here represent the June solstice for the Northern Hemisphere and the December solstice. Um, the sun will only appear kind of between these lines. Like this is the path the sun takes. It's either the highest path in the sky, which is the June solstice, or the lowest path in the sky. It's never going to be kind of over here or under here. The sun likes to stay right in this narrow region. The southern hemisphere sees a similar pattern, but it's kind of flipped. We'll be talking about the south celestial pole in the southern hemisphere. Just to be really explicit about it, these are some of the really important terms. So the celestial pole, for us in Albany, the important one is the celestial North Pole, but it's the apparent rotation axis. So Northern Hemisphere, it's marked by Polaris, which for us appears about 42 degrees above the ground, which is the same as our latitude. The celestial equator, right, the projection of Earth's equator, an apparent path of the sun at the equinox. We also have zenith, which is the point directly overhead, and then one we didn't really talk about, but nadir, which is directly downward. Okay, so we are modeling our view of the night sky as if we are sitting in the center of a slowly rotating sphere. Stars appear to travel through the sky as the night progresses, right? So what does this actually look like for us, right? So let's first pretend we're looking north. And so for us, we'll be looking towards Polaris and the North Celestial Pole. The North Star is part of a constellation called Ursa Minor. Um, but I usually can never find Ursa Minor. I look for the Big Dipper, right? Ursa Major here. Use these two stars as pointer stars to point directly to the North Pole, or the North Star, excuse me. So what you'll notice if you go out and observe the sky for hours, night after night, is that there is a region in the northern sky where it looks like the stars just travel around Polaris and never set, right? They never go below the horizon. So this is called the circumpolar region. And its exact extent, it changes depending on where you are. So if you're further north, more of the sky will be circumpolar. If you're closer to the equator, less of it will be circumpolar. But they kind of travel like this. So Ursa Major is circumpolar. It will appear to just travel in a big circle around the North Star, around Polaris. If you look in a different direction than north, if you look in some other direction, you'll see something different. If you look closer to the celestial equator, you will notice that the stars rise and set. So stars closer to the celestial equator are only visible part of the year and part of the night. So say we're looking east, we might see Orion and Gemini constellations rise, but they will eventually kind of set in the west. They won't just travel in a circle around the sky. If we were to set our camera and take a long exposure, we'd be able to tell which stars are circumpolar and which are not by checking out their star paths, like we saw at that picture at the beginning of this lesson. It's worth, I think, taking time to think about what the sky looks like in different parts of the world, right? So as we get closer to the equator, remember, the latitude goes down. It's a smaller latitude. As we get closer to the pole, the latitude goes up. So it goes from 0 degrees at the equator to 90 degrees at the North Pole. So once again, here around Albany, we're about 42 degrees. If we were to go down to about 30 degrees, we'd be somewhere in the vicinity of Florida. And if we go up 60 to 60 degrees, we would be kind of in Canada, southern part of Alaska, kind of that region. So if you're in the northern hemisphere, the further south you go, the closer the North Celestial Pole gets to the horizon. This means that the sun will take a higher path through the sky and the sunlight will be more direct. And at night, you will see fewer circumpolar stars, but you'll see more stars overall because the sky will be filled with stars that rise and set throughout the night. So this represents 34 degrees north latitude. So this represents kind of closer to the equator, and at every step along the way, December and the equinox and the June solstice, the sun takes a higher path through the sky. But as you go north, you will notice that Polaris will be higher and higher in the sky, and the sun will take a shallower path through the sky. More of the night sky will be circumpolar. So the further north you go, the bigger the circumpolar region is around Polaris, and you'll see fewer stars rise and set throughout the night, but you'll see more stars just travel in a circle around Polaris. And that's what this represents here. We're at about 68 degrees north latitude, and the sun takes a shallower path. But what happens kind of at the extremes, right? Maybe talk about the North Pole and the equator. What happens there? So let's first think about the North Pole. Right? So that's this is the schematic for the North Pole, 90 degrees north latitude. The North Celestial Pole is at its zenith, so right overhead. So what are the implications of that? So remember, the North Celestial Pole and the celestial equator are orthogonal to each other. So that is, they are 90 degrees from each other. So the sun travels along the celestial equator. So what is 90 degrees from straight up? It's kind of straight to the side, right? So the celestial equator is kind of more just straight along the horizon. So what this means is that the sun will take an almost flat path along the horizon, and every star in the sky will be circumpolar. You'll see the same stars traveling around Polaris night after night. So that is one extreme. What happens at the other extreme, at the equator? So we are over here. This is 0 degrees latitude. So in this situation, the North Celestial Pole is basically at the horizon. It's a flipped situation as compared to the North Pole. So we have the North Celestial Pole along kind of the horizon. And so the sun will travel almost directly overhead. And at night, you won't see any circumpolar stars. Every star will appear to rise and set. So here's kind of a summary slide of how stars appear to travel throughout the sky. So remember, at the North Pole, Polaris is at the zenith. So all stars are circumpolar, right? None of them set, they just swirl around Polaris. At the equator, we have the opposite situation. North Celestial Pole is on the horizon. So all stars will appear to rise and set, right? This red line is the horizon. So the stars will come up above the horizon, stay up for a while, and then set. And at intermediate latitudes, kind of where we are here, we get a mix of both, right? We have the North Celestial Pole. We have a region in which the stars are circumpolar, but then a lot of the sky where stars will rise and set. I've been talking specifically about the Northern Hemisphere, but we get kind of the same behavior pattern in the Southern Hemisphere. Only down in the Southern Hemisphere, Polaris is never visible, and you will see a totally different population of stars. Okay, so let's go back to this picture we saw at the beginning of class. So where do you think this was taken, just kind of generally? So look at the star trails, right? They're big arcs. It looks like Polaris might be somewhere kind of in here, in the middle of these concentric rings. But almost no stars are actually making a full circle around Polaris. Looks like we have a few right here, but most of the sky, the stars are rising and they're setting. So that means that this picture was probably taken on or very near the equator. In fact, it was taken in the Maldives, which is kind of this island nation, kind of straddling the equator. And we can tell that, maybe not the Maldives, but we can tell that it's near the equator simply by looking at these star trails and how few of the stars are actually make complete circles, are actually circumpolar. So I think that is about it for this particular lesson. Dr. Hassel, again, has made some great demo videos that I encourage you to watch before starting on your assignments. But let me know if you have any more questions.